Yeah.
Hello.
Good morning. Good
Yeah.
morning, Dr. Godwin.
Yeah, good morning.
Good morning. Good morning.
So I can pause the video during the presentation. Is it
Sir, your choice.
fine? And meanwhile, I have if somebody asks, I have some other arrangement also. Like I have a secondary camera to show my papers to write the equations and all.
Okay. How will we do that? How we will do that?
I have a secondary camera.
Okay.
So I will switch the camera. In that case, I will connect to the camera.
Okay. Okay, sir. I'm
So-
connected throughout the session. Don't worry. I'll be there.
Okay, fine.
Okay.
So I think we can start by around
After
10:25.
5 minutes.
Yeah, 10:25. Precious.
Okay.
I think it is okay, right?
Yes.
Yes, but that equation should be visible. Means you have to zoom or something like that.
Once. It is visible.
How to pin your distance.
Yeah, at the time, let me try.
Yeah, we will see. Yeah, I will share the screen. We'll see that.
I think only 2-3 slides. If they have any doubts, I have to clarify.
Okay, okay. I think, sir, we will start discussion at least. I'll introduce you and then you can start. You can tell about yourself, etc. Shall I start? Yeah, shall I start to introduce you? Shall I go ahead? Okay. So, good morning, everyone. Welcome to this 8th day of our faculty development program. And I hope you are enjoying our all sessions. Today, I'm very happy to announce our speaker, Dr. Godwin Anand. You heard his name from Mayuri Madam's during Mayuri Madam's speech, and I'm really happy that Godwin sir is with us. We were continuously interacting, I think, at least from last 1 month or so. And when I sent an email to him requesting for this FDP, he was very excited, and he immediately he actually he has given me a lot of suggestions basically. To the best of my capacity, I tried to pursue them. I don't know how much I could be, but thank you, sir. Thank you very much. And but that has given me a lot of boosting that we can carry out programs not only now but in future also. And Dr. Godwin will be with us. That is kind of a boosting that I have got. And it is my pleasure to introduce sir. And I'm very happy to see his profile when I have gone to his profile and the company he is leading and the technologies in which he is expert. I thought purpose of this workshop is fulfilled to some extent because I introduced the purpose of FDPs in data science on the day that we need to have a multidisciplinary culture and the faculty members from not only for computer, IT, but then other departments like electronics, mechanical, etc., etc. They also need to learn these technologies and they should go ahead. Correct. And when I was contacting various resource persons, I was very happy to see the profile of Dr. Godwin because he's basically an electronics or instrumentation engineer. That's what I could point out from his profile. Because his technical skills are PLC programming, LabVIEW, SCADA, embedded controllers programming, MATLAB, etc., etc. Apart from what computer IT skill sets are there. So I'm very happy to have a person who is going to bridge the gap. What computer IT domain is there and what electronics domain is there. So that's what I'm looking forward from Sir's session. He's currently holding the position of head research and training at the Omega Engineering Systems and Solutions. I think from September 2019. He helps in promoting and facilitating leading edge research, including collaborative and interdisciplinary research in the areas related to the goals of OEHS. He's very active in providing the sufficient support and training for a community of innovative researchers to enhance research capacity and to increase the internal and external research and also to increase the job opportunities. He's developing the networks between the research centers and researchers in the field of public and private sectors, locally, nationally, as well as internationally. He's a very renowned person, basically, at the national level also. He's having very, very good contacts in the data science domain, particularly. He's acting as a nexus between the company and the community with respect to the research initiatives of mutually beneficial linkages. It could be with the industry partnership, or it could be a collaborative research, or it could be transferring knowledge to society. He is very active in all this. He has conducted many research programs, training programs, seminars, workshops, etc. He worked as a head of the Department of Applied and Electronics and Instrumentation Engineering at St. Gates. He was professor in charge of the St. Gates. He was holding the LabVIEW Academy there, and he was also the member of various committees like Syllabus Committee of the department, etc. at the MG University. He actually headed the Cochin Institute of Science and Technology as a principal and looked after the general administration of the entire college, overall supervision of teaching, etc. He was looking like students' welfare, guiding to the teaching staff, non-teaching staff, and he's also guiding the research scholars at APJ Abdul Kalam Technological University, Kerala, and he's serving as a manuscript reviewer at many SCI-index journals. So I'm looking forward for Dr. Godwin, your session, because as I explained, you are the key link between our electronics, other domains, and our collab. I would say now MATLAB and collab words. And thank you very much for accepting this invitation and immediately accepting to give the demonstrations in the MATLAB, etc. Thanks a lot, sir. Thank you very much. Looking forward for your session. So I'm just transferring the access rights to you. Okay, sir.
Okay. Thank you, Rathod, Dr. Rathod, for giving me a very elaborate about my profile. So I don't want to speak much about me. So I will directly go into our presentation. Yeah. So I welcome all the participants for this AICT sponsored FDP on Insight into Intelligent Automation and Machine Learning and Data Science. So I think many of our speakers has spoke about regression, decision tree, various aspects of machine learning, data science. And I'm also talking about the similar thing, but in a slightly different manner. So I'll be handling today these are the topics I'm going to cover today. That is slightly giving an overview about machine learning and decision tree algorithm, random forest algorithm, support vector machines, some ensembles techniques, and some real-time case studies and recommendations. So here we are doing the case study using MATLAB. So as far as why we are going into MATLAB means, most of the electrical, electronics, automation engineers, they are all application engineers. So we are hectic in coding. So we have aware of MATLAB. So in that way, we done our case studies using MATLAB. So if you see, what is machine learning? Machine learning is nothing but in the real world, we are surrounded by humans. We learn by means of experience. That is what we learn from day-to-day life, and we absorb, grasp things that we call, and we educate ourselves. So this can machine do. So how we can able to make a machine to learn how we are learning. So this machine learning come into the domain of artificial intelligence. So naturally, humans are really born intelligent. Machines are trained intelligence. So what we do is make machine to learn. So is it possible? Yes, of course. Machine learning, what we can do is giving a set of data to the machine, and the machine will train according to some algorithms, learning algorithms. According to the learning algorithm, the machine will give the outcome. So based on that, we deal with the machine learning. So this is the concept of machine learning. Machine learning enables the machine to automatically learn from the data, improve the performance from experience, and predict things without being explicitly programmed. So it is nothing but we don't need a high-level programming for machine learning. So machine learning is a simple block diagram I have been mentioning here. So we need a set of training data, and the training data is given to some learning algorithms. So the learning algorithms will create a model, and the model will be again tested with some testing data. And according to the evaluation made, the model is corrected. So after that, we will give some unknown data so that it can able to predict the data. So the main thing is, first we have to feed the data. The data is given to the learning algorithm. The learning algorithm will do the model, or it will create a model based on some error calculation or evaluation, and the model will again tested with the testing data. Then it will give the prediction. So I think this is a simple overview of machine learning. This is a total concept. The data can be either a text data, a real world data like a continuous data, or a image data, whatsoever it is. So when we talk about that algorithm, any algorithm has to, the machine has to learn. We have to make the machine to learn. So when we consider the learning techniques, there are three kinds of learning. I think all of them, many of the speakers has been explained very well about this learning methods. I just touched because we focus main on supervised learning in our all algorithms. There are three kinds of learning: supervised, unsupervised, and reinforcement learning. If you see supervised learning is nothing but like, we will be corrected. What will be the outcome? If you give an input, the outcome, we know what will be the outcome. So based on that, we use the data. For example, labeled data, we call it as a labeled data. So for example, if this is a condition, then this is the output. So that we call it as a supervised learning. So supervised learning is a type of machine learning method in which we provide sample labeled data into the machine in order to train it on the basis of predict the output. So the main aim of this supervised learning is the data should be labeled. If we didn't label the data correctly, then our learning is not correct. So the final goal of the supervised learning is map input data with the output data, because we know which data is for which class. So that is main in the supervised learning. You see, unsupervised learning is learning ourselves without any prediction. For example, there are large set of data. For example, if the data is very huge, if you want to identify a dog or a character in thousands of lakhs of images, so this we give the data set like millions of images into the trained learning algorithm. What it do is it selects the features. So dog has some features. Dog has the height and it has the eyes. If you compare with the dog and cat, there will be some features, unique features for cat and unique features for dog. So what unsupervised learning does is it creates or it groups all these features, yet common features, parameters in a particular group with similar patterns. So this for unsupervised learning, we need a huge amount of data. So in deep learning, we use unsupervised learning. So, but we are not focusing on unsupervised learning in our learning algorithm. So I'll let with this. And reinforced learning is another one technique. This is mainly used in control systems. That is, we need a feedback. Feedback is like a sensor output is again given to an input. Where if a robotic arms move from left to right, that movement is again given to the learning algorithm. So if it is does correct, then a reward is given. If it is not up to the mark, and again that is a penalty is given for each wrong action. So these agent learners automatically feedbacks and improve the performances. So mainly this kind of reinforcement learning is used in control system, robotics. Mainly we use robotics. So if you see problem in machine learning, so machine learning can handle 3 different kinds of problem as of now. In future, it can be done many other application also. So far, as per now in literature, we go with 3 different kinds of problem. First, we go with classification. Classification problem is nothing but just a class. It belongs to a particular class like yes or no, or true or false, 1 or 0, or it is not either, right? It cannot be a binary, or it can be a 5 class, 6 class, or n number of classes. So if the classes increases, that the problem dimension is high. So mainly we focus this classification algorithms in today's lecture. So another one type is regression. So regressions is a type of continuous output. Continuous output means, for example, what will be the stock market tomorrow, based on that input GDP or something like that, or any company shareholders or any new project as announced. Accordingly, the model is developed. Then the output will be continuous. The best example for this one is system identification, a black box modeling. So black box modeling is nothing but if you use this kind of input, what will be the output in terms of continuous values? So we call it as a regressions. And another one, we call it as clustering. Clustering, it is like, like product recommendation. Product recommendation means when you buy a mobile phone from Amazon or Flipkart, and you will get a bundle offer. You can recommended products like, if you buy this, you can buy the headphone, cover, case, etc., etc. So based on one product, if you buy, so there will be some clusters. There are some requirement for the particular product. So that will come into the along with the clustering. That kind of problems we call it as a clustering type. So these are the basically 3 types. That is, one is classification, another one is regression, another one is clustering. So mainly we focus, today's lecture we talk about, we'll discuss about classification. Now let's see the application of machine learning. So in today's scenario, if you see the application of machine learning everywhere, when you open YouTube or when you open internet, everywhere machine learning. First we start with automatic language translation. There are many apps to convert English to some other language or regional language, or in English to German. So what does it do is not only the character recognition, but also the vocabulary, the sentence phrase, the meaning is not changed, that kind of application. That is, for a best example, Google Translator that use a machine learning technique to automatic language translation. Next one, if you see medical diagnosis, of course, many of the applications in medical field now use artificial intelligence for their diagnostic purpose. For example, doctor can do diagnosis, but again, there should be some benchmark, because it cannot directly rely only on the doctor expertise. So what the thing is, we can able to use this, assess this tool to diagnose or support the doctors to whether based on the image, they have any tumors, then what kind of tumor it is, or what kind of disease it is, for prediction of blood glucose, etc., etc. Stock market trading, that's what I said for regression type. This is many of the application, they are investing much lot in stock market trading, because we don't know what will be the share price tomorrow. So we will have the input, and we don't have the correct reasoning capability to what will happen to the share. So based on the past history, we will become developing a model. That model will able to predict some accuracy, and it may give an insight about what will happen to the share tomorrow, or what will be the share market trend tomorrow. Next, online fraud detection. Online fraud detection is one of the thing used in credit card user login. So if for example, when you are using a credit card and you are purchasing in your hometown, if you go for some vacation and all, again, if you use a swipe a credit card, immediately you will get a mail whether this is you or not. So it will read the geographical location, what location the card is used. So again, somebody unauthentically log into your account or try to log into your account, immediately you will get a notification whether it is you or not. So that kind of application is called online fraud detection. Virtual personal assistant, that is for we can have some navigation systems like if some pedestrians cross, it give a virtual warning in kind of automobile industry will be using, and navigation purpose we'll be using this one, virtual personal assistant. Email spam malware filtering. Email spam malware filtering, if you see last 15 years back, we will get all spam mail, bulk mail in the same inbox. Today, recent email inbox, we doesn't get any bulk mail or spam mail in our inbox. Then that is called as a promotions or like spam. How does it do? So this Google, their system admin, they do that. They install this machine learning methods to classify this email into whether it is malware or spam. Everything it is. Self-driving cars, that is one interesting. That is the current research it is going on, like Tesla, Uber, this kind of cars, they are in the research. That is autonomous driving cars. So it doesn't need a driver. So based on that virtual sensor inputs, it will do the self-driving itself. Product recommendation also similarly, like what I said for Amazon. Then traffic prediction. Traffic prediction means based on the past learning, it will say tomorrow at 9 o'clock that this will be the road will be congested. If you see in a Google application, when you open and see the time of a particular shop, it will be busy, and you can see a histogram for that. 9 o'clock or 1 o'clock, it will be very busy. Based on the customers entering into the mall or particular shop, based on that, it will recommend. That is also one of the traffic prediction. Speech recognition, that is like various application we are using to recognize who is like voice activated. So if you open, it can able to recognize your voice. Even Alexa uses this one, recognize some voice, or you can able to access, unlock your phone. That is also. So these are some of the application. Even every application we can use machine learning. So classification algorithm we are going to deal with. As we know, the supervised machine learning algorithm broadly classified in the regression and classification. In the regression algorithm, we have predicted the output in a continuous value, but in the predicted categorical values, we need classification algorithm. So classification algorithm, most of the applications, these algorithms we are using for classification. So this we have already seen. The classification algorithm supervised learning technique used for identify the category of new observation basis on the training data. And learners from the given data or observation, then the classify new observation into a number of classes or group, such as yes, no, spam, not, cat, dog, etc. And it is called the target labels. So in today's lecture, we will be focusing on decision tree, random forest, support vector machine, and these three we'll be discussing. And I think other three are there: logical regression, Navy basis, and KNN. So decision tree is one of the basic, simplest machine learning algorithm. And random forest is an example of ensemble method, but it uses again decision tree. A single tree, if you use a single tree, it is called as a decision tree. When you use a multiple decision tree and form an algorithm, then it comes in the class of random forest. And support vector machine is slightly modified of logistic regression method. And we use support vector machine for various applications like classification of images. Most of the application will be using. Decision tree. Decision tree is a supervised learning technique that can be used for both classification and regression problems. But mostly it is preferred for solving classification problem. Actually, I told that it is a tree-like structure where it represents nodes, branches, leaves, etc. In a decision tree, there are two nodes. One is the leaf node and the decision node. Leaf node is the end node, and the decision nodes are the branches node. And if you see a decision tree, it is nothing but everybody can easily understand. It is a graphical representation for getting all possible solution in a problem based on the given conditions. So, in order to build a decision tree, we use CART algorithm, that is classification regression tree algorithm. That is the standard form. We call it as a CART algorithm. And we ask a question like, yes, no question. Because a decision tree works like a human thinking. Human thinking in the sense, whether I have to decide or not. Based on the possibility or probability, our real-day life, based on our probability, we will decide some actions. Similarly, the decision tree also do the same. So, if you see the representation, it is a top-down approach. So it goes from top to bottom. So first, the decision node, that we call it as a root node. Then it comes under sub-node, that is a decision node, that we call it as a subtree, that we call it as a branch. We call it as a branch. And the next one is the leaf node. Leaf node will give the end decision, whether we can have the decision or not. So that we call it as a leaf node. So if you see decision of the root node, for example, today it will rain. Yes, no. If yes, stop the play. No, we can continue play. In that way, the decision tree, the regression takes place, and accordingly, it will come from at the end, there will be only one case. That is called the leaf node. So these are some terminologies. Root node. Root node is from where the decision tree starts. It represents the entire data where the divided into two or more homogeneous sets. I think it must minimum it has to give two sets, and it can go for a number of sets. The leaf node, there are the final node, and that is the end node. That is the final condition. It is satisfied the condition, and this is a decision. And splitting is a process of deciding that is a node. That is a branch node. We call it as a second node. That is a splitting. The branch or subtree, a tree is formed by the splitting from the subnode. Pruning is nothing but it is another one of the good technique. So when we create a decision tree, the tree will go big. So at that time, in real-time life also, when you grow a tree, we will cut the unwanted branches, which is not required for that. Whether the tree, what is our objective of the tree, it has to deliver some fruits or not. So in that way, we have to cut the unwanted branches. Similarly, the pruning is a process to remove the unwanted branches from the tree. So parent or child node, there's another sub node, we call it as a child node. So this is a simple algorithm. It is a 5-step algorithm. So it starts with the S, complete data. The data set we call it as S set data. From the best attributes, we have to select. That we'll discuss what is a arbitrary selection measure. So we have to divide the subsets that contain possible values of the best attributes. Then generate the decision tree nodes which contain the best attributes. So we have to do basically which is the best attributes. So there are some indexes of that. So to find the performance measure. Until then, we have to do the iterations, and finally we have to do the best tree which is suitable for the application. So I think so it is a 5-step process, and it is quietly very easy to understand. Why you use decision tree? There are various algorithms in machine learning, but this decision tree, why we are using, there are mainly 2 reasons that I think I already told. It may mimic human thinking ability while making a decision. So it is very easy to understand. The logic behind the decision tree can be easily understood. So when we look into an algorithm, anybody can able to easily visualize what is happening inside a decision tree. For example, if you say Anand, there are a lot of mathematics. If you take a SVM, there are a lot of mathematics involved. But in decision tree, there is only simple mathematics, a simple equation that gives all the algorithm to work very fine. So this is one of the major issues, that is when we select that attribute nothing but what are the, in the data set there will be various headers. In that where each header is called each attributes. So when we select a particular attribute, the results will go accordingly, and the size of the tree also grow according to the selection of the attribute. So while implementing the decision tree, we must be very cautious so that which attribute gives the best value or the best tree or best classifier. So there are 2 ASM techniques. That is, one is called information gain, another one is called GeneIndex. Information gain, I think everybody knows. Information is gain of change in the entropy. Entropy, many of the applications we use entropy after to find the information or find the what is that okay. So in that entropy is not normally it's a physics word. How much data we can, how much information we can able to extract from the particular data, that we call it as a entropy. If you go by entropy method, what we have to do is we have to have when the entropy is 0, then there is we call it as the system is having very correct information. With the entropy is high, then the system is having very clumsy of data. We cannot have a correct information. So when we draw a tree, the root node will have high entropy and the leaf node will have 0 entropy. So in that way, the tree has to be defined. So if you see that Information gain is nothing but entropy S, that is minus weighted average into entropy of each features. Entropy is nothing but probability of log, S log into probability of S minus P log, that is no probability of no. So it is a very simple formula to calculate using entropy. So it is your choice whether you can go for entropy or GeneIndex. GeneIndex, we call it as a impurity measurement. So GeneIndex uses CART algorithm to find the tree. Based on the algorithm, each node has to measure the GeneIndex. So based on the GeneIndex, if the GeneIndex is high, then if the low GeneIndex should be the preferred answer compared to the high GeneIndex. The attribute with the low GeneIndex should be the preferred answer compared to the high index. That is, when we have the GeneIndex high, that is, it has a good value. The split is very correct. So the formula is 1 minus summation of pj squared. That is probability of yes no, the summation of probability of yes no. When we do a application, we can able to see that. So I think we will go with an example. In this example, we are using a GeneIndex to calculate the measure, that are arbitrary measures. So if you see the data, there are 333 data. I'm just showing a small example. So here there are 3 attributes. That is, one is chest pain, glucose blood circulation. If you see this one, chest pain, glucose blood circulation, blocked arteries. These are the 3 attributes. Based on these 3, we have to make a system or a tree whether it has heart disease or not, whether we want to know whether we are having heart disease or not, or the particular data is having heart disease or not. So this we have to form a decision tree. The first thing what you have to do is which attributes we have to select, whether you have to select chest pain, good blood circulation, or blocked arteries. So we don't know which one is having, because the data is 333, we cannot able to calculate each and individual every row. For understanding purpose, we are giving for 5 simple data here. So which one we have to select? First, we go with chest pain. So if you select the chest pain as a attribute, there are 2 classes. One is true and another one is false. True, another one is false. If you see chest pain, heart disease, yes, that is 105 says yes. And no heart disease, 39. And if there is chest pain, if there is heart disease, there is no heart disease, and there is for yes is 34 and no is 125. You got it how it is? Chest pain, true, this is true. Heart disease, yes, this is yes. If you have chest pain, yes, and something, if you have chest pain, yes, and heart disease, no here. Because since there is 333 data, 303 data, so we'll put no here. This false case, chest pain, false. This is chest pain, false. So if it is no, then this is yes. And this is no. Similarly, we will calculate these values. And similarly, we're doing for the next attribute, that is blood glucose calculation. And again for blocked artery, 3 things. According to the root node, which one we have to select. So we don't know, still we don't know which node we are going to select. We don't know which node we are going to select. So with the help of GeneIndex, we are going to select this one. See, the total number of patients with heart disease is different for chest pain, a good blood circulation, blocked arteries, and see, each data is different. And we cannot have a concrete decision to select which one will be the best attribute. So what we do is, because none of the leaf node gives 100% yes or 100% no, so consider all are impure. So you can consider all of, because we didn't get a concrete yes, no. So what is the way to separate? Go for measure the impurity. So first we go with the chest pain. For this node, how we calculate the impurity is 1 minus the probability of S squared minus the probability of no squared. Okay, this is the simple formula. The formula for 1 minus S105. This is a 105. And the probability means you have to take this two. 105 plus 39. 105 plus 39. That is to the whole power raise. So minus the probability of no. Probability of no is, what is this? 39. Minus divided by the total data. That is 105. That is whole square. If you calculate, we will get 3.395. You got how we are calculating this one? Chest pain, say yes, 105, no 39. So 1 minus probability of S. Probability of S is total samples divided by, S samples divided by the total samples, and no samples divided by the total samples to the whole power. That is, we getting 0.395. The same way we have to calculate for the other node. The same way we have to calculate for the other node. Because it is not necessary this has 144 patients and this have 159 patients. So totally we have 303 patients. Totally we have 303 patients. So the impurity of this one is 0.395 and this is 0.336. Not only this, then again we have to calculate the total gene impurity of the chest pain. Now this is for yes and this is for no. This branch is for no. Right side, this is 0.395 is for yes and 0.336 for no. So the total impurity is a weighted average of gene impurities is nothing but, see here, 144 divided by, this is our total 144 plus 159 divided by 144 into the impurity, and this value same divided by 159. This is 159 into the weighted average, that is the gene impurity. So I think you got it, how you getting this one. So this is calculated for chest pain. If you select the attribute as chest pain, we are getting 0.364. If you are selecting good blood circulation, we are getting 0.360. Blocked arteries is 381. Which one is the minimum? We have to look into it. So 0.360 is the minimum one. So 0.360 is the minimum one. So we think when it has the minimum impurity, then we can select that attribute as the root node. Then our classification will be good compared to the other two. If you select other two, the tree will be big. So we will get the optimal tree here. Okay, now we have selected good circulation as a root node. The same way, if you calculate the attribute as a good blood circulation, yes, again we go with the heart disease, yes, 37, no, 127, heart disease, no, yes, 100, no, 33. The same principle we have to follow for the other this node. If you follow this same principle, this node has, we can, whether we want to select chest pain in this node or blocked arteries in the node. So accordingly, which one is having the minimum one? So minimum one is having blocked arteries. So we will go with blocked arteries. So blocked arteries we are going. Again, the same thing we have to do here. Good circulation, blocked arteries, chest pain. So when you see here, so if you see this chest pain, again, what is happening here? We are getting 17 by 3 and 7 by 22. So majority of the saying is yes, and here majority of saying no. So we can stop here. That is considered as a leaf node. So again, if you see here, this we say block here yes, here no. So 13 by 1 or 2. So we can say here this is we can stop here because we have major says as no. Here major says as no. Here major says as yes. So we can stop here. So how we can stop? Again, we have a doubt whether we want to stop this or not. And if this impurity is lesser, this impurity is lesser, we can, if this impurity is lesser than any other node, we can stop here. If the impurity is greater, we have to select the lesser impurity node. See, for example, again, you can have chest pain here. The impurity is 0.29. So here is 0.2. So we can stop this node accordingly. So we can consider this as a leaf node. The same way, we have to do the same steps and calculate the gene impurity scores. And the lowest score has to be the splitting node, and the final will have the highest value. So this way, we have seen this one. So if you see the, now we have seen the data with respect to category. Yes, no, yes, no. If blocked artery is yes, no, yes, no. So same way, if you have some weight factor, weight is a continuous value, it's a numeric data. So how we can do that if we have a numeric data? So that is also very simple. So if you have a numeric data, if you have weight, so what the first thing is, what we have to do is sort this weight in ascending order first. So this, the weight is 155 pounds. So from this 155 to 255 pounds. So in that way, we have to sort it. And you take, either you can take, if the data set is high, you can take 3 values and take the average. 2 values, you can take the average. If you take the average by 2 values, we will have more number of attributes. So if you have average of 3, then we'll have somewhat the total data set will be divided by 3. If we divide by 2, the average if we take by 2, then the total data set divided by 2, that accordingly. So the same principle. See, you have to check 167, the weight average is this one, and again for this one, again for this one, calculate all this thing. The same formula we have to take for this one. So for, if you see, you have taken 5 data here, 1, 2, 3, 4, 5. If you take 5 value and we will get 4 average. and which one is having that gene impurity is minimum one. So we take 205. So weight less than 205 will be the top node, that is the root node. From that, we can able to do the procedure as we have done earlier. So this is the thing we are using in for continuous values. Okay, 1 second. I think you have understood, but technically speaking, we are not going to do anything manually like this in our machine learning algorithm. These are the things which we have to understand for our these are the concept behind the decision tree, so that when we do when we select algorithm from MATLAB or when we select algorithm from Python, what we have to do, there are some they'll say decision tree GeneIndex. If you say GeneIndex, how it is going to function, how the tree is developed, so that we must know some fundamentals. These are the fundamentals, the theory and the mathematics behind the decision tree. So if he doesn't know this thing, and if you do the application and we get something, means there is no point in use how the backend is working. So technically speaking, we are not going to do manually here, but for understanding, we are doing this thing. But in the algorithm, it will select the optimal way based on these calculations. Hope you got it. I think you have understood the now we'll go for random forest algorithm. So random forest algorithm is one of the modified algorithm. It is a combination of ensemble and decision tree. So when we call it as more number of tree, we call it as a forest. In a forest, there will be number of trees. And similarly, the same concept, they have used the random forest, because why it is random forest means the data are selected randomly. That is, the seed from the data are selected randomly. And that's why it is called random. Random forest is a popular machine learning algorithm that belongs to a supervised machine learning technique. It can be used for both classification and regression problems. But it is based on the concept of ensemble learning, which is a process of combining multiple classifiers to solve a complex problem and to improve the performance of the model. Why random forest? It has a unique advantage compared to decision tree. For example, when we decision tree that has a biasing nature. Biasing nature means, for example, when you go for a movie, I'm a Shah Rukh Khan fan. Then I say, how is the movie? Since it's a Shah Rukh Khan movie, and immediately I'll say the movie was wonderful. But actually, because of Shah Rukh Khan fan, I'm saying the movie was wonderful. But that is not the case. When we do analysis, how that story was there, actor is one of the attributes, story is one of the attributes, and songs, fight, etc., are various attributes. So since I am a Shah Rukh Khan fan, I say the movie was fine. But when you see the script, based on the script, maybe it may be poor, or maybe the fight or action sequence, that will be poor. So based on that will be good. In that way, sometimes good or bad, we doesn't know. But in random forest algorithm, it is not the case. The random forest algorithm, what it does is, each tree will have different attributes. Each tree will have different attributes for different random data, and it will do the learning, and it will find the classifier is defined. So that's why the random forest algorithm is much popular than the decision tree. Hope you got the concept why random forest is much popular than the decision tree. Random forest classifier that contains a number of decision tree on a variable subset that given in the data takes the average to improve the predictive accuracy of the data set. Instead of relying, that's what I said, instead of relying on one decision tree, the random forest takes a prediction from each tree based on the majority votes of the predictions. The final output, the greater number of in the forest leads to higher accuracy and prevents the problem of overfitting. Overfitting is another limitation in the decision tree. When the tree is very large, when we use a generalized data, we cannot able to get the correct predictions. But when the tree is not as big, then the tree is more generalized model. So when we have number of trees, that the tree size will be small, so that it can prevent overfitting. So that is one of the advantage which can be compared with the decision tree also. The biasing problem is there, as well as the overfitting. Overfitting is one of the advantage. Otherwise, if instead of random forest, if we go with the decision tree, the problem is we will have a number of trees. The tree size will be big, and it will work fine for the training data. It works better for the training data, and it won't work fine for the testing data. It works fine for the training data, and it won't work for the testing data. So that we call it as a overfitting. So this is a simple representation of random forest algorithm. So training set, the training data 1, training data 2, training data n. This we call it as a tree 1, tree 2, tree 3. So this training data are selected from this training sets, randomly selected from the training sets. So randomly selected from the training sets, and that can be, the training data can be same number or different number, or it all dependent. So it can be this. The overlaps of data can be allowed to around 35%, maximum of 35%, the overlapping. So minimum 60% data should be unique. So this tree will perform and give a decision, and this tree will perform a decision, and this tree will perform a decision. And here voting takes place. Voting means this, for example, from a basket, I'm taking a fruit, and that fruit is classified, and the first tree will say I'm taking a fruit called apple, green apple. One decision tree will say apple. The second tree will say apple. Third tree will say it is an orange. The fourth tree will say it is an orange, and fifth tree say it is an apple. So if you take the average voting, there is 3 apple and 2 orange. Now what will be the prediction? The prediction will be apple. So we can get the correct output based on the average voting. So that is why the random forest is much better than the decision tree. We can have much better accuracy in the random forest algorithm. I think you have understood the basic concept in random forest. Assumption for random forest. Since the random forest combines multiple trees to predict the class of data set, it is possible that some decision tree may predict the correct output while others may not. But together, all these tree predict the correct output. Therefore, below there are two assumptions. One is the should be some actual values in the future variable. The data should classify predict the actual results and the guessed result. The predictor from tree must be very low correlations. That's what very low correlations means. The tree should be, it should not be very big actually compared to that original decision tree. When you go for random forest, the tree should be very small. The actual values and data should be classified predict the result should be 60%. That is the minimum. That is one of the major requirement. There is 60%. Then only we can able to predict much. It gives a much accuracy. Why you use random forest? Because all trees are executed in a parallel form. When we start a decision tree, it runs from top to bottom. And if you have n number of trees, the n number of trees start the same execution from top to bottom at the same time. So if a tree is big, it takes 5 milliseconds. If you use 5 trees, then it takes 3 milliseconds or 2 milliseconds. So the tree size is very small. It predicts output with high accuracy even for large data sets. It runs effectively because we are subsplitting the large data into small samples, and that's what it does use very effectively. It can maintain accuracy with a large proportion of data is missing. So there are if some classes we don't have that proper attributes. In that case, when you go with the random forest, we can have the best, or it can able to predict the output if some attributes are missing. So here, the algorithm, similar 5 steps: select random k data from the training set, build the random data. So build the decision tree associated with the selected data point. That is the subsets. That is called a number of trees. We call it as. Choose the number n for the decision that we want to build. Repeat the step 1 to 2. And here also we use the GeneIndex or entropy to calculate the how in a random forest there will be number of trees. Each tree will do the same procedure what you have seen in the decision tree algorithm. The same concept, but only one thing is the outcome will be the average of voting average. That is the difference between the decision tree and the random forest algorithm. So here we will see a small example. Here we are having a data set of 9 days, whether the match was played or not in the particular day. So here the attributes are outlook, humidity, and wind. The label is on the prediction is play. So whether we want to play or not based on the output. So when we do with decision tree, we'll have a very big tree. So how we are going to split the data, let's see. Or how we are going to create the number of trees. So here we are having the original data. In the original data we have 9 tree. We are having subsets 1, 2, 3. This is tree 1, this is tree 2, and this is tree 3. So there are some overlappings are there. Here I have not selected randomly, but I selected by for easy understanding. I took D1, D2, D3. Here D3, D4, D5, D6, D7, D8, D9. Every subset need to be distinct. Not to be distinct. Some set may be overlap. See, there can be not to be distinct means either can be distinct or not to be distinct. So whether we can have a distinct subsets or size is different also. So first, it goes with overcast. Here, if you say the tree node is wind, humidity. Here it is wind, it is humidity, and here it is also humidity, and again here wind. So if you see overcast, no, yes. If it is overcast, yes, play. If you see the first one, if it is overcast, play, yes. Play. No, then again we are taking wind. Here we are wind is we are having two things. So wind, weak, weak. So play. Strong, no play. So overcast, wind, weak, play. Overcast. So when we give overcast, there are two. Wind is strong, no play. Then finally we are having two leaf node here. That is play. This is one tree. This similarly we are having for the data set 3, 4, 5, 6. The next tree. See the tree size. Each tree will not be the same size, and the attributes will not be the same. So how far, if you see the chance of play here for overcast, that is 2 out of 3. That is 1, 2, 3 leaf node. 1, 2, 3 leaf node. Out of 3, that is 3 data, so 3 leaf node. 1, 2, 3. So out of 3, 2 says yes. So it says play is the final decision from the decision tree 1. And next one, if you see D3, D4, D5, D6, again here also 1, 2, 3, 4, 5. Out of 5, 3 says play. So here also play is recommended. Here, in the similar thing here also, overcast, yes, play, no, humidity high, no, play. So here also play. So finally play will be selected. Finally, play will be selected. So in this way, decision tree is random for in the decision tree. In the random forest decision tree will have the efficient way to predict the output compared to the normal decision tree. So the main thing is most of the application we go with random forest algorithm. Since the computation time is slow, the complexity is less. That's why, and the overfitting problem is eliminated in the decision tree. So in the random forest, so that we can able to use this algorithm for various applications. So now we have completed decision tree, random forest, and then we will have a support vector machine. Okay. Support vector machine is one of the interesting algorithm, and this algorithm use both for classification as well as regression problem. Support vector algorithm is a modification of logical regression. So that is because logical regressions, they deal with two-dimensional problem. In support vector, we call it as we can use a higher dimension problem. We call it as the goal of the SVM is to create the best decision boundary that can segregate the n-dimensional space into class. We can easily put the new data points correctly category in the future. Best boundary called as hyperplane. So the difference between this regressions, logical regressions, and hyperplane is there will be a line, here will be a hyperplane. So it can do for two-dimension problem as well as n-dimension problem. So we will see that how we can able to done in SVM. So this is a simple understanding of it is a two-class problem. If it is a two-class problem, means there will be blue is one case and green is another, round is another class. So there will be a hyperplane. This is called the hyperplane. This hyperplane, if there is only one hyperplane, we call it as a logical regressor, either this greater or this. So here there comes called two hyperplane. That is called as a positive hyperplane, and another one is called negative hyperplane. The positive hyperplane and negative hyperplane is drawn parallelly to the maximum margin. That is the hyperplane. That is a maximum margin line that is drawn parallelly to the this one. So the main aim of this one is to increase the margin of the hyperplane, maximum margin. So when we increase the margin, then only it can be classified, the error classification error will be less. So the support vectors are very important to create the positive hyperplane and negative hyperplane. So how, let's see how this hyperplane creates the given impact into the SVM. See, this support vector machine maximize the margin around the. See, there are two hyperplanes. I have drawn two hyperplanes here. This is the first one and the second one. So the hyperplane margin should be higher. So if the margin is narrow, our classification is not very accurate. If there will be a chance of overlapping of data, whether the class A will fall into class B. For training data, it will be okay. For testing data, when we give other data. So our main aim is to classify. We have to draw a hyperplane. That means a maximum number of points has to be covered in the cut through the positive hyperplane and the negative hyperplane, so that the margin will be high. So you can see this. So don't worry that we want to draw that. We are not going to draw any hyperplane. All the SVM algorithm inside the computer, they will do that. It will do it. And the only thing is the logic behind, we have to find it. So this is one of the optimization function that we have to create the maximum hyperplane. So hyperplane, there can be a multiple lines decision boundary to segregate the class in n-dimensional space. But we need to find the best decision boundary that helps to classify the data point. The best boundary is known as the hyperplane of SVM. So I told that earlier, there will be not one hyperplane in a classifier, where we can draw a multiple number of hyperplanes, but the hyperplane should be have maximum margin. Then only it can be have a better. It can be considered as a better classifier. So the dimension of the hyperplane depends on the feature present in the data set. There are two features shown in the image where I have shown already. It will create a maximum margin as through the data points, which is called the support vectors. The support vectors, there is positive, that is a class A, or if it is a two-dimensional problem, the line which is passing through the class A, the nearest point to the hyperplane. So the parallel line drawn accordingly, that is, this is the parallel line. This is the maximum object. This is a main hyperplane, and this is the support vectors. So that these two are called as support vectors. So these things will determine the margin of the hyperplane. So if you take an SVM, there are two types of SVM, linear and non-linear SVM. So many applications, real world applications, there is no, we cannot say the problem is linear. For our explanation, we saw class A, class B, but in a real problem, we are not getting that kind of data. So we'll see in the examples and all. And so we use nonlinear SVM. Nonlinear SVM, we use kernels and classifier, nonlinear classifiers that we'll see later. So this is maximum margin formalization. W is the decision hyperplane, that is a normal vector. Xi is a data point on I. Y is a class of data point. So Xi is a support vectors, that is a hyperplane, and Y is the data class. So if you take the classifier F of Xi is the sign of W transpose Xi plus B. This is the characteristic equation. How we will show how we are deriving these equations. And the functional margin Xi is Ya, that is this we call it as a margin. So this is the optimization function that we will be seeing here. So it is a class problem. It is two class problem. Either it can be +1 or it can be -1. So the distance from that is R. So this is the distance R. How we are going to calculate this R? R is this is the expression we got, and we will show how we are going to derive these expressions. And the margin, that is a rho, is the margin. This is called the rho. That is a rho margin. And this is a vector. This is a direction. So the direction is from x dash to x. That is a direction. That is, if you see here, how to find R. R is the dotted line. If you see x dash x, it's perpendicular to the decision. This is perpendicular to the decision. So the W will be parallel to the unit vector. That is W by W, that is norm of W. So the line we can, this is a unit vector, so it can be R W by norm of W. We can write it as R norm of W. So x dash, we can say x minus YR W by norm of W. And this is a condition we have to say W transpose X plus B equal to 0. This is a condition that we have already seen here. This is a condition. And from that, we can able to recollect this one, that is R is equal to Y W transpose X plus B by W. So how we are going to get this, we will see. So this is okay. this is, for example, if you draw a line like this, this line is passing through the origin. This line is passing through the origin. Okay. So if it is, this line is passing through the origin, and this is W transpose X plus B is equal to 0. That is W transpose, this is the origin line, so we are saying this is W transpose, this is 0. And when it passed through the origin, we see this characteristic equation. We can able to remember one equation. What is this? This is nothing but a slope. Y is equal to mx plus c. Y is equal to mx plus c. This is the slope. So now we say this is passing through the origin. This is when it passes through the origin, our characteristic equation is W transpose X. Let us assume one point here. This is the negative side and this is the positive side. This is the negative side and this is the positive side. So whether I want to explain in paper or it is okay. So I want to derive in paper this one, this equation, how this equation comes to this one. If you want to derive in paper, say yes. I can arrange one in the chat box. Okay. So if I take a point here, for example, it is 3 comma, for example, the point I am taking this one, this is origin. And if I take this point, this is, for example, 3 comma 0. And I take a point here, this is this is minus 3 comma 0. And this is 3 comma 1. We can say assume like this, 3 comma 1. So what is the equation y is equal to mx plus c? That is W transpose. W transpose means what you can do is, what is W transpose? What is the slope here? It is passing through the origin. The slope will be minus 1. Minus 1 divided by, minus 1 transpose. That is minus 1, 0 into x. That is x. What is x? X is equal to minus 3, 0. Minus 3, 0. So what will you get when you do the multiplication? B is equal to 0. Then because it passes through the origin, so there won't be any B here. So what will be B equal to 0? Then we'll get a positive value because minus slope is minus 1. This is passing minus 1. So we can assume this as 1. So we can assume this as 1. And similarly, if you take this one, y is equal to, so here the matrix is minus 1, 0, and the point is 3, 1. So 3, 1. If you again calculate, it is 3 minus 3. So this is, we put as, it comes under minus. So what is the category? Anything comes under this class, we call it as positive. Anything comes under this class, we call it as positive. Anything this comes under this class, we call it as negative. Anything, this is one group and this is a one group. Any class, we call it, comes here as a positive, negative, and this, positive and this is negative. So this, for this, we are getting this one equation, W transpose Xi plus B greater than 1. We are writing this equation, and W transpose Xi plus B less than or equal to -1. So from that, based on this concept, we are able to deriving this one. So this is a hyperplane which is on zero, that is a zero hyperplane, and this is the main thing. What we have to do is we have to find the difference. Yes.
Short, give the following short answer. Banana color.
Hello. One second. Yeah. So here, what we want to find this is the distance. We want to find the distance. So that is the maximum margin. The maximum margin is nothing but x1 minus or x2 minus x1. We can find the difference between these two, x2 minus x1. So this is one equation. This is one equation. From these two, we can, if you subtract by these two, we can be able to get an equation. So W transpose x2 plus b equal to 1 minus W transpose plus b equal to -1. If you subtract these two, we will get this. What do you get? W transpose x2 minus x1 equal to 2. Because this, when you subtract this from this, we will get 2. So this is 2. So what we do is divided by this 2 by norm of W. What you have to do is divide this equation I by norm of W. So when we divide the norm of W, the direction what will go, the vector will go, and we will get 2 by norm of W. 2 by norm of W. This is the hyperplane. That is the distance. So our main aim is to maximize this function. Our aim is to maximize the function. The maximize the function is we have to have an objective function. We'll have an objective function. In this objective function, we have to maximize. The objective function is nothing but 2 by norm of W is the objective function. So how we are going to do that? So what we have to do is we have to find, so that we have to do this optimization. So again, this can be maximized, and if you take this, can be considered as a minimum function also. This is a maximized function, and it can be considered as a minimum function also. How can we convert as a minimum function? Inverse it. When we inverse it, we will get the minimum function. So that's what rho is equal to 2 by norm of W. This is a margin. So when we minimize this, W by 2, we will get, according to that, we can able to derive it. So I think when you go on next slide, I think I can able to explain clearly. So what is that? We can, the quadratic, this is a quadratic equation. We can find W and B such that rho is equal to 2 by norm of W is maximized for all xi comma yi. So these are the two conditions. Wt is for 1 if I is equal to 1, and this is -1 for y is equal to -1. So these are the two conditions. These two conditions are the constraints, and this is has to be maximized. So when we will do the minimization problem, the minimization problem is a better formula is a minimum. So we have to find the minimum of, so minimum of this one is, what is W? Norm of W? Norm of W is equal to nothing but 1 by 2 W transpose W is minimized. So this is why our minimization function is done. So we are converting a maximized problem to a minimized problem by inversing it. So 2 comes down, W transpose W. Instead of now, here we are having the directions also. So soft margin classification, because the real world problem and all, it cannot be classified with an exact straight line. Because many points, if you draw an exact straight line, we cannot design a classifier because all data will be overlapping. So we want to have not hard margin. Hard margin is a regression. We can have a soft margin. Soft margin, otherwise called as a slack variable, we call it as a theta. The slack variable is nothing but we can allow number of points to have overlap. This point, for example, this point, this red point, if you see in the hyperplane, there are some red point. There are some blue points here. So we can allow our classifier to have certain number of points to overlap, so that my gain of the hyperplane will be high. So if we allow some of the point not to overlap, then our classifier, that is the margin of the hyperplane, will be very narrow. So to overcome that, we have to have a trade-off between, if you are having 1,000 data sets, allowing 10 data to overlap is not a big thing. So the accuracy will be reduced by 0.1. Accuracy will be reduced by 0.1. So we will get 99.9. We will get 99%. Sorry, accuracy will be reduced by 1%. So if you have 1,000 data, normally SVA model will go for 10,000 to 20,000 data. In that cases, we allow a more number of variables to overlap between both positive and negative hyperplane. So then only our classifier will be effective. Now simply our real world problem will not be in a mutual, we cannot able to really classify exactly. So that is sorry, the training data is not linearly separable. A slack variable theta I can be added to allow the misclassification of difficult or noisy examples. Allow some errors. Let some sample point to move where they belongs to at a cost. That is, cost means a trade-off. Still try to minimize the training set errors and place a hyperplane far from each class a large margin. That's what I'm saying, that we must have a trade-off to allow whether our algorithm should have this much accuracy, but with some errors I can able to allow the classifier. So if you see the soft margin classification mathematically, similarly both the things are same. Only thing in the slack variable, if you add the slack variable here, there is C and theta I is added. C and theta I, that is summation of theta I, and remaining these two, this is same for a linear. If you add a slack variable, this is a problem. This slack variable is nothing but, what is C? C is the number of elements. For example, we are allowing around 10 data points to overlap. So C is equal to 10. And theta I is equal to the summation of theta I is equal to nothing but the 10 variable have the distance. See, for example, this is one variable. This variable have a distance. So this has a distance of this much. So summation of theta I, this is theta I, theta j. So theta, if you add this one, this for here it is given only two variables. So here only given two variables, the summation of this two. So for example, this is 3 and this is 4. So 3 plus 4 is equal to 7. and how many variable? 2 variable. So here C is equal to 2 and zeta I is nothing but 7. So in that way, we can able to classify, because most of the SPM, we allow soft margins. Hard margin does not give it is not a very good classifier. So in many of the application, we used to configure soft margin, that error, how many error we have to give. In that way, we will be doing. So the summary of this linear classifier, the classifier is separating the hyperplane. Most important training points are support vectors. They define the hyperplane. This is a quadratic optimization algorithm, which is a non-zero Lagrangian multiplier. That is, this alpha is nothing but the constraints. Both the dual formation of the problem. So appear inside, because that we'll see in the example. So nonlinear SVMs. So I think this point, the data set are linear separable with some noise to avoid together. So this is a hyperplane. It is in one dimension. So we can put a straight line and we can have 2 support vectors here, and we can classify this one easily. But can we classify with this one? We cannot able to classify this one because we'll get 100% error. We are not 100. We will get either 100 or more than 50% error. If you're getting more than 50% error, then it is not a classifier. So if you do a single dimension, a single classifier, we cannot able to do this classification. See, blue set is one of the data, and the red set is another type of data. So we want to classify blue and red. So whether a single line can classify this one, it is not possible. So what we can do is, that is the advantages of SVM. In nonlinear SVM, it will convert 2 dimension to high dimension problem. It converts 2 dimension into high dimension problem. This high dimension problem, what else it does is convert this 2D into another dimension, that is 3 dimension or 4 dimension, so that the data will be spread in a different way. If you see this, it is again considered into 3 dimension. This is in 1 dimension, and now it is converted into 2 dimension. In this 2 dimension, if you see this one, if you draw a straight line here, it can be separated easily. So this comes under one class and this comes under another class. So now it is a single dimension. So it cannot be separable. Now it is considered the 2 dimension. It can be separable. If the 2 dimension data is also overlapping, then you have to go for 3 dimension. So how in that way we will be separating. See, this is a higher dimension problem. This is a 2 dimension problem. It is a visualization of the data. There is no possibility of having a hyperplane to separate blue and red. So what we can do is convert this to a higher dimension, 3 dimension again. If we convert this to 3 dimension, and we can able to see the class, so that is the transformation here. X is equal to, that is a function of x. So this function is nothing but size of the function, which is converting the dimension. So that then we can draw a hyperplane here, so that we can able to have a very good classifier. So that way in nonlinear, so this is done use of kernels. The kernel is one of the, we call it as a kernel tree. So it is a highly mathematical involvement here. So the deriving, to give a lecture on this PPT is very difficult. The linear classifier lays the interval between the vectors. So nothing but here some transformation is done. One second. Yeah, a kernel function excuse me. Yeah, if every data point mapped into a higher dimension, somewhere transformation, I said, this phi is nothing but we need to have some transformation. That is whether what dimension, that function, that has to be transferred. So that is a mathematics involved in it. The inner product becomes, that is similarly, this is just for understanding. The kernel function is nothing but we have talked many times. Make a non-separable problem to separate map data in a better representative space. We know there are common kernels like linear, polynomial, and radial basis. So in our toolbox, when you use this, we just go to select kernel and just configure the values. That is more than enough. And accordingly, it will do that. Because none of the classifier, we cannot come into a single step. So we will do the tuning, fine tuning based on various trial and error function. So accordingly, we will do it. So can you have a break of 10 minutes or 5 minutes?
Yes, sir. Sir, when we will start exactly MATLAB? After how much time this will take? Hello, Godwin sir, can you hear me? Okay, sir. But 10 minutes break.
No, sir. Can you hear me?
Yeah, sir, I can hear you.
Can I have a break for 5 minutes?
Yeah. We can have 10 minutes break. 10,
Yeah, okay.
10 minutes break we will take. Sir, these PPTs will take how much time?
This PPT will be completing in another 10 slides.
Ach. Because
Another
MATLAB,
10 slides.
yeah.
Yeah,
On
another 10.
MATLAB you will have to show also, no?
Yeah. So we will start by around um,
Okay. Okay, sir. Okay. Okay.
Hello, sir. Hello. I think I'm going with some case study with MATLAB. And participants, you can unmute your mic. You can ask any doubt, any questions you can ask. And one at a time you can ask. And so that the session will be interactive. So after, if we find time, we'll go for ensembles methods. Okay, we will go with some case study and recommendations, how we are doing, and real-time applications using MATLAB. Okay, shall we start the session?
Yes, sir. Please start.
Okay. So I have two case studies. Basically, one is a basic one, and another one is some research applications. First one is to create a model to identify the activity of the user through mobile accelerometer sensor. So here, what we are doing is collect the data from your mobile, process the data using MATLAB, that is labeling, then classifier selection, training, testing, validation. These are the basic process of a machine learning system, what we have discussed in the first slide. So now I will share my MATLAB. Okay. So this is one of the app in your mobile app we can download from Play Store. That is sensor reader, or there are many apps like read the sensor from your mobile phone. So with the help of the sensors, we can able to track the data of your accelerometer. You can put the app on their open this app, and you just put the record button, select the sensor record button, and you can do your activity. And what you have to do is collect the data and export to MATLAB in the form of Excel or CSV. But you can use CSV, text, Excel file, any file you can able to read in the MATLAB. So in that way, we are collecting. My problem is I have taken a 3 classification, like one is standing, walking, running. Three, my accelerometer. This is my accelerometer. Accelerometer is nothing but it gives with respect to XYZ direction based on my activity. That is, when I was walking, the acceleration will be small. Running or standing, it will be idle, or there will be some noise. In that way, the accelerometer. These are the 3 data we have taken. That is acceleration versus time. That is with respect to X, Y, and Z. So with this three data, I am able to classifying my data for my application, like whether I was standing or walking or running. So here around, we have taken around 5,000 data here. 5,000 data. This 5,000 data, we are going to do some applications. So we'll go to MATLAB. So I think many of you are aware of MATLAB. MATLAB exclusively for people in circuit branches, they use MATLAB. Actually, there are now this recent MATLAB 2018, 19, 20 is there. This is 2019 version. 2018 also doing the same thing. And there are lots of toolboxes. MATLAB is a general thing. In these toolboxes, we will have various apps like curve fitting, optimization, PID. So this is similar to this one. Every colleges will have that. So you just go to here, search, and you can able to do that applications and everything. Here, if you click here in the search application, you can do the what are the toolbox in listed in your systems. So here we will be using toolbox called machine learning and deep learning, but we are not going to do deep learning. We are going to do machine learning classification learner algorithm. So regression is a different algorithm, and classification is a different application, and regression is a different application. So far we have seen only classification. We will do an example according to the classification. So just click the toolbox or application. We will get a normalized window. So in this normalized window, and this is the learner window. So what is the first step for do our classification? Collecting data. Data is one of the major thing. Collecting the data for do our classification applications. So first go. If you have any doubt, you can raise the question. I can explain one more time. So I have saved the data from my mobile to my laptop. From that app, I saved as an Excel file. So what from file, if I open, see, this is the data. See, this is the three variables I showed in the graph. This is acceleration, and this is with respect to x-axis, this is with respect to y-axis, and this is with respect to z-axis. These are all numbers. These are all numbers. Okay, and this is a class that is running. See, here it is running, walking, standing. So there are around 4,500 some data in which we will be importing this data directly. We can store the data in the form of Excel file, and directly we can able to call the Excel file in this app and open the file, then import selection. See, there are three inputs with respect to x, y, and z. Acceleration input with respect to x, y, z, and there are class. There are three categorical class, three unique classes are there. That is, what are the three classes? Standing, running, and walking. These are the three classes. You can see the range of this. So if you see, there are how many data? That is 4,597 data are there, and it is 4 table. How many data we are giving? As far as the classifier will do better. So what type of validation we need? Like we want to have a cross validation, holdout validation. If you want to have holdout validation, you can go for 25%. Or if you want to cross validation, 5-fold, 3-fold, 2-fold. That is this is for if the data set is very small, we can able to go for cross validation. If the data set is very large, we can go for higher validation. So how we can go for holdout validation, and we can have 25% data to validate our classifier. So after training, If, for example, we have selected 4, 5, 9, 7. Out of this, 25% data will be tested. 25% data will be tested. 25% data will be around 1,175 data will be tested. So, okay, 1,057 samples will be tested. So we'll go for 25%, hold out cross-validation, and start session. See, here we are going for, see our data. This is our data. I told you, can you able to, if you imagine this data, see, running is blue. It is widely spread. The spectrum is broad. Standing is very small. If you see, this is standing data. So that is why standing data is very small, because there is no movement in my accelerometer. So that vibrations or movements is very less. So the sample is very small. And if I go for walking, and the spectrum is somewhat wider. And if you go for running, can you able to have a classifier, SVM, linear SVM? Not at all. We want to have a different classifier, so that kernel, we need to have a very good kernel, then only we can able to do it with this. So what we have to do is, first we will check with the decision tree. A decision tree will do fine, but whether the accuracy will not that much as 100% or 99%, in that way it will not be that. So we'll go for what type of classifier we need. There are many trees: fine tree, medium tree, chorus tree. That is, fine tree is nothing but the tree size is very big. Medium tree, the tree size will be small. Chorus is very small. So this is only a decision tree. So let me go with medium tree and settings. Number of splits, that is, we are going to configure this. None of the system will have these parameters. We doesn't know for which parameter it will give a better accuracy or better classification or less error. And only thing is, here the stopping criteria is we are discussed about Gini. So we are providing GeneIndex. So we are subjected dissociation splits. That is branching. We are cutting the branch that we are putting off. So when you put on, how much nodes we have to cut it. That is. So better we try with off. These are the basic two things. Configuration we have to set up here. That is, one is number of splits, split criteria. What performance measure we have to take, GeneIndex. Okay, that's all. Then just train it. We got 95.5% accuracy. See, the accuracy is 95. Prediction speed. Prediction speed is one of the main matter, that is 74,000 objects per second. That is very fast. When you create a model, this model will be very fast, so that it can able to do very fastly. It can able to calculate the prediction. If you give input, the time. This is training. We don't want to bother about the training time, but this is the prediction speed is very fast. 74,000 objects per second. That is, we can give 74,000 samples, then immediately that capability this tree has right now. So here, finally, how we have to find out? It is very simple. That is only thing is confusion matrix. The confusion matrix shows how the error classification is done. So this is the confusion matrix. There are three classes: running, standing, walking. Here, running, standing, walking. How many, I told you, how many data we are using for predicting. The data is around 25%, that is around 1175 data. 1150 data, roughly, plus or minus 10. This, if you add all this data, it will come 1150. So if you see the running 318, there are few errors. The errors are, if you see, the class. So predicted value 94%, it is good for running, standing 98%, and 94% for walking. Do you have any idea about this results outcome? False discovery rate is 6% for running and walking, standing 2%. Because if you see the classification data, the standing data is in a small domain. That is, the frequency of the data lies between the particular domain. Walking and running, sometimes I may run slowly. That takes as a category of walking also. That is very hard to describe at some moment of time, because sometimes running, and we need to have another mechanism to categorize running and walking, because speed walking considered as a slow running. So that this overlapping is done by 6% and 6%. So this is a model validation, and when we have designed a model that it consists of total percentage 95.9, 95.5% accuracy model, so that it can able to predict if I generate this app and put it into and develop and convert this model. We can export this model. We can export to model, and we can cross compile it. We can generate in C code. Whatever model if you want to generate, we can able to generate it. Either we can convert to Python, or we can download this to a machine learner, a microcontroller, whatever application we can able to do it. So once if you generate this model, we can develop an app. That app, if I put it into my pocket, in the mobile, and if you put it in my pocket, and it shows what is my activities, whether I was sitting, I was standing, or running, etc., etc. If I have, for identification, I have just used 3 class. So that, so you have a doubt, sir, why don't you try with the find tree? So let's we try with find tree. So maximum number of split, it is given 100. So previously we went with, so find tree means the tree size is large. So when we go for a big tree size, I told that there will be a chance for overfitting data. It works well for, let me try. Have you seen this? It is really interesting, because it gives a better response for training data. It gives better this error. Previously we got how much? 95.5, but this error is This one 94, here it is 92. Here it is 94, here it is 95. See, here it happens what is running 92, actually 99. Here 1% we have increased, here it is 8%. So total if you see 8%, 5%, 6%, 1%. Actually we got previously also 98%, but this is reduced. This is because of overfitting. So if you reduce the split, if you reduce the split means the tree size is going to reduce. So for example, if you put 50, definitely our performance is going to improve. Yeah, see, it is 96. So now it is 66%. That is, now when we reduce the tree size, the overfitting error can be reduced. This we are now visualizing in our application. You've got to understand that is the limitation of a decision tree. If the tree size is very big, definitely our data will be overfitting. So that we must try to avoid the tree in an optimal way. So I think it will give better for 30 or 40. Yeah, again increase 96.4. So 99, 95, 96, we got 4115. So this is the way we have to be. Once we must have the idea, then we can. There is no rule of thumb says this should be this much, this should be that much. See, this prediction speed is much faster. Sorry, this is 33. It is very. See the training time. It is very much higher. So there are other methods. Now we'll see SVM, because it is not linearly separable process. So we go to Gaussian. These are all the kernel scales, level, what type of kernel function, linear, quadratic, cubic. So these are the various kernel functions which we have discussed earlier. See, it gives accuracy of 87%. This is fine Gaussian. This is chorus Gaussian. We have to go for fine Gaussian. Okay. Now the accuracy has increased. See, if you see the prediction speed, this is 66,000. If you see the prediction speed for decision tree, that is 330,000. So from this, we can come to a conclusion. Many of them have doubt. Which algorithm we want to use? Whether, sir, this is giving 97.8% accuracy, so that I can go for SVM, fine SVM. And my decision tree is giving only 96.4%. So I can go for, I am going to select 97.8, but that is not the fact. We must have a trade-off. I want to have an application that has to be predicted fast. That means I have to go for decision tree. I want more accuracy. I want 1% accuracy. See, where is 337 samples per second, and where is 66,000 samples. That is far different. That is 313 five times faster. My decision tree algorithm works 5 times faster than the SVM, because SVM have lot of mathematics involved in it. So it takes a calculation time. So it, according to that, it will do the calculation, do the conversions, everything. So decision tree is very simple. So when you want accuracy more and the prediction speed might be less, we can go for SVM. And if you want the prediction speed is very high, then we can go for, in my case, if I recommend to go for decision tree based on the results, because this much sample times I can able to give it. Because there is no necessary for having, I don't want to have the tree because the data is very big. So if I draw a tree with 50 branches and all, it is very difficult. So we cannot able to calculate mathematically and all. So only thing is we are using a decision tree of this much split. This is a GeneIndex. That thing I can able to tell. And another type is there. SVM we have seen, decision tree we have seen, and what we have seen, random forest. Random forest is a type of ensemble classifier. Can you able to see this? Ensembles classifier. So here we are using bag, boot, subspaced. So we can go for bag. Here maximum number of splits. So here the maximum number of splits is, I think why it is 4599. Number of learners. That is number of learners is 30. Number of learners is 30 means there is 30 trees are there. Number of splits is nothing but number of each tree has. For example, we are using decision tree. In the decision tree, we have certain one decision tree we have used around 50, right? 30 into 50, 1,500. So roughly we can put 1,500. Let's see. Or 1,200 we can put. That is 4 3s are 12. That is each tree has 4 splits. 40 splits. So here I'm getting 97.3. But again, the speed is less. Prediction speed is 18,000. So again, whether, speed is 18,000. So whether I have to go for ensemble method or a decision tree method, for my, there is one point you have to remember. No algorithm is better for any of the problem. So each algorithm will work better for different problem. So for this problem, I go decision tree is works very well for this application. See, if you see this 97, and this is the ROC curve. See how accuracy it is there. Here it is 99 point. So I have to get a perfect square. So if the point relay on here, then it is running and standing. Standing, I am getting very perfect. Accuracy is 100. So I am getting 100. Walking, same, not 100. Because standing, if the data is entirely different compared with the running data and walking data. Because the domain, you see that in that scatter plot, this is data. If you see the data, standing is only just a part. So it is very easy to separate. And it is heavy overlap here. So this is that this thing, and we can export this model to workspace, train model. It can able to go load in the workspace. From that, we can able to do some S-file or applications, and we can able to do that. Any doubt in this regarding, or if you want to generate functions, we can able to generate. This is a function. This is a code. I think as we are all circuit engineers, we have some sicknesses coding. So better there is an app which is available in MATLAB, so we can use that app, and we don't want to code anything. If you have idea, as far as we have ideas, and we can explore our ideas, and our ideas can be not limited with the coding. So if you have idea, we can use this toolbox, and you can explore various applications. And when you have various medical data, image data, whatsoever it is, you can able to do with this MATLAB function, because and that the tuning is based on fully trial and error. There is no proper tuning method available so far. It is basically mainly done using trial and error method based on your application. Finally, selecting that, recommending that classifier, we must select, that should be a trade-off. Which one we want to have the higher priority, whether that prediction time or simulation time or model accuracy, these things we have to check into it. You have any doubt on this, please you can ask right now, and I can go for another question. Anybody having any doubt? Are you audible?
Yes, sir, you are audible. Sir, which was that app? Sensor data you do?
That app is, 1 second.
Because I have the app related to sensor in my mobile, but that is not recording the data. It simply shows the coordinates.
Yeah, that is, I'll show. You can see my camera?
We can see you.
Yeah, okay. 1 second. I'll show. I have to take my camera. I cannot see my camera thing. Yeah. I'll show this. This is the physics toolbox. Physics toolbox.
Physics.
Physics toolbox.
Okay.
And you can able to see that data. And if you press this red button, it will save in Excel file. Sensor data collect. Actually, you search in Google sensor data collect. There are a number of apps. So next one. This is one of the highest problem, the real-time terrain identification of autonomous robot using machine learning. And this is one of the This is one of our research paper, one of my student research paper, real-time terrain identification of autonomous robot using machine learning. And I'll show the simulation also. So here, what we have done is the robot has to move on to the terrain, that is irregular surfaces. Based on that, the system has to identify which terrain it is going. Accordingly, the control system has to be manipulated. So that is one of the important thing, because many of the time we think that robot is going on the normal road. So accordingly, the control system will act. So when we feed the data, we are going on a higher terrain, so that the power or the torque of the motor will be increased according to the terrain. So here is this is a robot. Yeah, this is a robot. Here we are having an onboard controller. This controller will have around 16 sensors are there in the controller. This controller will pass the data, and we can able to communicate the data to the MATLAB, and directly we can record from the MATLAB. So first we are running the robot in different terrain, and we are labeling, because this is a classification problem and it is a supervised learning method. So first we are running on a flat surface, and we are running on we are idle, and it is moving right now, and it is coming down, and it is moving up, one wheel up, left wheel up, and left wheel down to the terrain. There are around 11 terrain condition and continuous rough surface. So based on this idea, we have to give to the controller when the robot is going at which terrain. So based on that, it has to classify and say my robot is moving into the particular location. So increase the speed of the increase the torque of the right wheel. So if you are running, so now you see that the higher end cost these applications are there. This is similar application like to an autonomous car. So autonomous car, we need to, it is automatic, it has to drive. So when there are more people in our car, we raise our escalator. But in autonomous car, the car should know that there are 5 people, so that the torque is, we have to apply more torque. So that way, these machine learning techniques, this will give the information or the class whether it is going on which surface. For example, this is applied in the Mars rover. So Mars rover or any rovers which is going to space, we don't know the terrain. So when the wheel goes right side, we have to apply the correct torque on the particular wheel. So that is one of the application, and this paper has published recently in 2020, and it is in Springer. So I'm going to explain what is core inside this paper. So this is the concept, and we have run this robot in various conditions, and we have collected the data, and the data is around 48,000 data. 48,000 data is a huge number of data, so that we can able to have a very good classification. So that we'll see, and I think decision tree, these things and all will not support that much of huge number of data, because the class is very high. Because we are having 13 category here, sorry, 11 category. This is continuous rough moving down. So this 13 category, we have to look into it. So we will see. Can you able to see the screen? Can you able to see the screen?
Yes, sir.
So here I am going to take new session. Sorry. From file. That is atomic ground vehicle data. Yeah. Can you see this? This is the very sensor gyroscope 1, that is gyroscope with respect to x, y, z, accelerator with respect to x, y, z. Sorry, this is gravitational force, gravitational sensor, acceleration due to gravity. This is accelerometer. This is gyroscope. This is orientation. This is rotation. And finally, the action. So if you see, there are a huge amount of data. I cannot able to scroll down. So that with this data, we can classify this 11 categories. It is, if you see the data, it will be, sorry. Okay. So now I am importing the data. First, I selected only one column. That is the problem. Okay. Here, if you see 11 category, 11 unique. So 16 variables. So that is 16 attributes we have taken into account. And with the 16 attribute, we are classifying 11 classes. So we are going for cross validation 5 folds, or holder where we can go for 25. Let's see both of the things we can check. Start session. See the data. You cannot able to imagine how to separate the data. This is, and it will be, if you see the scan, this is the original data how we are getting here. And see the overlaps. This data is overlapped with this one is overlapped with this one. Every data are overlapped, but I think we can able to class some of the area. See this, everything is overlapped. So I think decision we'll go with find decision tree advanced. Since we have 11 classes, we can go for 100 splits. See the accuracy, it is 89.8%. So 89.8% for control system is not allowed. So for that, we can able to go for higher method. I think ensemble KNN, we can go for KNN method. Substrate KNN. This is a new technique. See the accuracy. This is 100%. If you see the accuracy, it is 100%. Training times it took high, but the sample seconds is 16,000 samples per second. Since that, because it is you are using KNN, it takes much time. If you see the confusion matrix, see the 11 cases they reported 100%. 10 cases 1 is 99. Only 1 is 99, rest of them are 100%. So it is one of the best classification. And if you can able to come down little more by subspace scan and nearest neighborhood, number of learners, we can able to reduce the number of learners so that our prediction time will be less. So we can go with around 15 dimension, we can 5. Now the accuracy is 99.9. The accuracy is 99.9. However, see the prediction speed. The previous prediction speed is 16,000. Now the prediction speed is 39,000. So which one you want to have the importance? Whether my model has 99.9% accuracy, and I can go with the prediction speed is 39. So I can go with the following settings. Else I have to go with the other settings. So this is one of the thing we can use. And the confusion matter is, if you see, most of the thing, everything is perfectly classified. Flat, ideal. You know why we got 100% accuracy is a reason we have having more sufficient data. More sufficient data is around 45,000 data, 47,000 data we are using for 11 classes. So that what machine learns is how much we give training, how much we give input, accordingly to learn, like human also. If you learn many books, you'll have more idea. Similarly, machine will have, if you give more data, it will give a good output. The same way machine learning works. So any doubt in MATLAB or this thing? Participants, you can ask. Any questions from participants? I think it is quite easy when you do machine learning with MATLAB. Any idea about that? Huh? It is quite easy. Once if you know the logics or the parameters, it is quite easy to do with MATLAB. We don't want to stuck with coding, no syntax error, nothing. It reduces lots of time, and we can focus on our development of algorithm. Ratu sir, any idea? Any feedback?
No, I don't know. People should interact with you.
They are not interacting. That's what I'm asking. Whether they put the mobile on listen mode and they are doing other works, or
any doubt, anyone? No.
I think, see, based on this development, collecting the data, and we have put in a journal with impact factor, SEA journal. This is a work we have done. But only thing is, collecting the data is very important. we must have a good data. That is the main thing. Yes. So I think only thing is we can do, if you have MATLAB, we can do machine learning. We don't have to rely on any data. We can design your own application. For example, like prediction, temperature prediction. You can collect the data from the Android Arduino sensor or various applications, and we can do our prediction model. Many applications there are for IoT. Many applications are there. Whether today it will rain or not, in that kind of application, we can put anemometer, wind speed, everything. And for image also, we are doing image. We can also do. So image we have to convert to image to data. Then again we have to classify. That is that. So here the options are there. Directly we can get figures, export to figures. Directly we can export any figures, and we can copy this and we can able to put it in our Word document or any document. We can present it. So confusion matrix, if you do go for machine learning, confusion matrix is one of the important thing in which we can able to determine that accuracy with the help of the confusion matrix. The main idea is if you want to design any machine learning algorithm, we must know the fundamental of the particular algorithm. And if you know the fundamental of the particular algorithm only, we can able to write the theory concept in our paper. Not only result, nobody will accept. So we have to give the proper justification and this thing. So, any questions? So we'll go with ensembles.
Yes, sir. We'll go with ensembles.
Okay, nobody is asking it. I hope they have only understood or not understood. They are in two class. It's okay. Ensembles method. It is another method. We have like a similar like a decision random forest. In this random forest, we use only decision tree. But in ensemble, we use different classifiers or different learners. So here, there's different learners will have different. One have decision tree, one has SVM, one has KNN, one neural network, and combine of all this, we will get the output. So that is one of the advantage in ensembles method. In ensembles method only, we have shown our example that has provided 100% accuracy, because it not only learn with it is a subset ensemble with KNN. So there we have used only KNN with various kernels or these things. So value of ensemble, when combination of multiple independent diverse, the decision of each which is the least more accurate than random guessing. The random errors can help each other and correct decision and reinforce. So for example, it is similar to like how an individual will guess a thing. If I that is like individual estimate average. How many jelly bean in the beans? If I take a handful of jelly bean and if I estimate, I will get an answer. if someone estimate that they'll get another answer. So continuously 5 or 6 people estimate, they will get different answer. If you put the average, it will be correct instead of having one particular value. So this is like a audience opinion instead of a single opinion. It is like an audience opinion. It uses a single arbitrary learning algorithm but multiple training data to make it a learning homogeneous. There are homogeneous ensembles. We use a single learning algorithm but manipulate the training data. The same thing we have used in our robotics application. We use a single ensemble that is called KNN. So the data is different because we selected various different data. So data method for changing the training data, 2 types are there: bagging, boosting, decorate. Decorate is the recent one. Bagging is a resampling of training data. Boosting is reweighting of training data. Decorate is adding additional artificial training data. So bagging and boosting is a common thing we can avail in various literatures. These 2 methods we got developed on, that is bagging was developed in 1996. Repeatedly random resamplings by the training data. The training data n size create m samples size of n by drawing n examples from the original data. That is m samples of n size, because when our training data is 1000, m samples are the size of 1000. That is the thing. And the bootstrap sample, that is the average 63%, 63.2%, the data should be unique. That means we should have a constraint over there. I have to select 63 data without any repetition. And other than that, the repetition can happen. And using various learners, we can able to conclude using the majority vote by the making average or majority voting. Boosting originally developed by it was 1990, and it was redefined by called AdaBoost using 1996. So both the bagging and boosting algorithm both are evolved during late 90s, because 96 only, and this boosting basically based on giving some additional weightage in new that is bags, that is training sets. The first training set will have randomly will be selecting. After that, based on the evaluation, the boosting, we have to boost some of the weak learners. So accordingly, we will be boosting, and the training accuracy should not be less greater than 5%. That is 0.5. That is 50%. So based on that, we will boost the weak learners so that we will have a overall performances a very good outcome. So experiment results and examples that we are having some comparative study which is done on 96. That is wide improved generalized accuracy of wide variety of problems. On average, boosting provides a larger increase in accuracy on bagging. Because based on the study, boosting provides larger increases in accuracy than bagging. Okay, boosting, that's what I said. Bagging, we say based on voting. Boosting, we take on averaging. So bagging consists of, a random forest consists of bagging. Boosting, in Ensembles other method, we use boosting method, that is bootstrap. Boosting on rare accuracy can degrade accuracy. See, boosting is nothing but adding some bias over the values. When we boost according to that, the factors is not determined correctly, we are going to spoil the algorithm. So that it definitely degrade that. So that anything, the gain of the amplifier should be correct value. If you cannot put the gain accordingly. So the boosting parameter has to be designed correct way so that constant improvement in the subsequent samples. Boosting is particularly subject to overfitting when there is significant noise in the training data. That is, boosting, I told that when when we are using a sample data for training, we are giving some boosting parameters. So when we give a boosting parameter, the training data, the testing data is not same as the training data. So that when we use testing data, it don't fit into that. So that when the boosting is not done properly, so that it leads to overfitting. That is one of the drawbacks in boosting. Decorate is one of the recent, in 2003 it was developed. This is a new artificial technique that is instead of that data, we will be creating different data with the help of the same data. With, for example, if you take mean of the particular data, if for example we have 5 attributes, if you take the 5 mean of attribute 1 mean, attribute 2 mean, attribute 3 mean, in that way we can able to derive the various data by in a new way. That is called a decorator. This is nowadays they have incorporated in the various machine learning algorithms, but we doesn't know what internal they are giving, either what type of this thing. So improves accuracy when the training set is small. Therefore, resampling and reweighting training data is limited ability to generate the database of the data. Okay, so that's what it's saying. When the data set is very small, how many times if we resample, the same thing is going to come. So that when we use other technique to create some artificial data with a resemblance to the original data, so that it can able to, we can have a data size small and different training set, so that it can able to achieve much better performance. So how it is done for decorate? So the left side, that is that blue color shade is the training data. Training data, and based on the new from the data, it is given to the classifier 1. Next one, combining these two, classifier 2 will land, and again, see if you see that plus minus minus, this is a previous one, and it has a different data. It is not the same. And again the classifier 3. So this data, if you go by this way, we can able to add, we will have this artificial examples data means we will be developing some data based on the training data. That data will be considered to create the classifiers learners. So that way we can able to overcome the data which is when the sample size is small, we can come with this kind of learning bagging technique, that is decorate technique. So these are the advantages of Ensembles method, and we have seen 3 methods: tagging, boosting, and decorate. I think the decorate, they don't describe much detail in any of the things. This is one of the latest algorithm in various papers. They are now doing this one. So finally, I conclude my presentation. Thank you. You have any queries you can ask? So this is our email. You can, if you have any queries, you can mail it, and we will respond accordingly. If you have any help regarding.
Participants, any queries?
Machine learning is very simple. Just understand the logics and you work.
So thank you very much, sir. Godwin, sir, thanks a lot for sharing your knowledge and taking the session. It is 3 hour session continuously. Thank you very much. And I'll be looking forward for more interactions from you in the future as well.
Thank you very much.
Yeah, and probably this is the only session we had introduced to MATLAB. Otherwise, all sessions they were on Colab and other tools. So probably a different kind of a diversion and a different kind of insight also. So thanks a lot. Thank you very much. And you have been given the details in a simplified manner for all the algorithms. Thanks, and kindly accept this our virtual memento, we call it.
Okay.
Thank you very much.
Participants. Thank you, participants. Thank you, Ratu sir.
Thanks, sir. Thank you very much. Thanks a lot. So participants will meet in the evening, 5 o'clock.